So this is an explanation of the geometric mean problems. Alright, so first of all, this is the triangle you were given. I'm just using the problem that's from that first warm-up we did. Okay? And so what I did differently was that in this problem it only labeled here y, and I went ahead and put y on both sides. Okay? Now that seems kind of silly, but I have to separate the triangles, so I'm going to show you like why we need to label them. Alright, so for finding x, when I taught this, I just said, here is your pattern, here's what you're going to do every time. And that was x, sorry, 4 over x, so 4 over x equals x over the entire length, 9. Okay, but why? Why does this work? So the question is, what are you comparing? You're comparing the small triangle, because you're given these two lengths here, and you're also comparing it to the big triangle because you have the hypotenuse here, and you have this leg of the triangle. So to see that better, let's take them apart, okay? So we just need the small and the big, so we don't need the medium size. Okay, so we need the small triangle, and we need the large triangle. Alright, now, in this particular unit we studied was on similar triangles, and that is when you set up proportions. So I want my triangles facing the same direction. So this is close to the same direction, but not quite. If I flip this over, then we have the same direction, right? So, but we need to label this. So this one here is x, this is my right angle, and then that was 9. Alright, now that we have the triangles going the same direction, we can compare. So my goal is to find x, that's the hypotenuse. 4 is my leg, so I said leg of the small triangle. So leg of the small triangle, over the leg of the large triangle. And then we compare that to the hypotenuse of the small triangle. So x over 9, and 9 is your hypotenuse of the large triangle. Okay? When you set this up, the geometric mean basically is saying that your x value should be on the diagonal, or whatever unknown variable is on the diagonal. So then I would do 4 times 9 is 36. X times x is x squared. If I square root both sides, x is 6. So that would be the first problem. Okay. The second problem, to find y, I'm going to go ahead and set up the triangle back. Okay, so let's get the triangle back to the original format. Alright, so now, to find the y value, I have, it looks like legs here, and then these are also legs. And so I want to separate these triangles out, and I want to keep just the middle, the medium size, and the small size. So what are we comparing? We're comparing the small triangle and the medium-sized triangle. Okay, and every time I give you this problem, and we're finding that leg here in the middle, I set it up the pattern that it was 4 over y equals y over 5. But the question is, why is that? So let's go ahead and make these triangles look like the same thing. So we're going to switch this around. Okay, we don't need x because we already found it. So we're comparing the y, the 4, and the 5. So I'm going to do the small legs. Compare those. So the small leg of the small triangle and the small leg of the medium triangle. So that would be 4 over y. This equals the longer leg, so longer leg of the small triangle and the longer leg of the medium-sized triangle. Okay? So 4 over y and then you can compare y over 5. And then y times y is y squared. 4 times 5 is 20. Square root both sides, and then usually it says leave your answer in radical form. So if we go ahead and simplify this, what am I doing? Sorry, 2 and 10, so that would be 2 and 5, so 2 radical 5 because we have a pair of 2's. So that's x. Okay, so hopefully this helps you understand like what you're comparing. It is harder to see when the triangles are all grouped together, but when they're separated out, you see that you're comparing like the same sides to each other, like the small leg, the small leg, the long leg, the long leg. Hopefully this helps you. And then I'll keep this up on unit 7 in case you have questions on how to do this. This will be unit 7. Okay.